We're funded by Greylock Partners and Shasta Ventures. And what we do is that we provide sort of a platform for writing reactive applications. I mean, our three sort of core products are the Scala programming language, the Akka middleware, EventDriven middleware for scaling up and out, and the Play web framework. So, I'm really excited to be here. Some of our customers are listed here, as you can see. I mean, we sort of cut across a whole bunch of different verticals. So it's a very generic platform. You can see our customer using us in the telecom industry, so betting, gaming, I mean, e-commerce, shops, social media, in hardware industry like routing and investment banking, merchant banking, etc. So the challenge and sort of the problem that we, with our platform, trying to solve is that the world is changing really around us, and how software is being built today. Sort of the fundamental premises are changing. I mean, today applications are need to be deployed on a wide range of different infrastructures, like all the way from like mobile devices all the way up to like huge cloud computing architectures, like from one node up to thousands of nodes. And it's really ever-changing demand, right? And also this new trend towards multicore architectures is also something that's pretty challenging. So it's really scaling out both on your local machine as well as scaling out into multiple machines. And historically, I mean, you've used sort of many different tools to solve these different problems, but I believe that there's sort of the fundamental problem that you should have a cohesive single sort of way, a single programming model, a single runtime actually to take care of for you. So also things, I mean, the users nowadays have way higher demands for like SLAs, low latency, throughput, and stuff like that. So I really believe that we need new tools, and you basically have to rethink the way we address these issues. Okay. So we need systems that react to events. Most systems today, I mean, are somehow event driven. I mean, either through the way they are used or how they are integrated with other tools, other systems, etc. We need to be able to react to load. I mean, sometimes pretty unpredictable load. We need to be able to react to failure. Resilience needs to be built in. We need to react to rich and very engaging UI. And all of these things brought together is what we call reactive applications. And these four traits, I think, are all fundamental and sort of support each other in a very cohesive way. I'll try to illustrate that throughout this talk. So starting with event-driven. The benefits with event-driven architectures is that you get way more efficient resource utilization, and under heavy load, I mean, you will both increase throughput and lower latency, even though there actually technically is sort of a trade-off between these two. And perhaps even most importantly, you will get a very loosely coupled architecture that is easier to extend, maintain, and evolve over time. So how can we then make this happen? I think that we need to really start thinking about architecture, our system, using asynchronous message sending, embracing event-driven architecture at its core. And the second sort of trait of event-driven architecture is non-blocking. And as soon as you sit on a resource, then you like impede progress for others. So it's very important that the runtime has a way of dealing with that so you can actually suspend components that's not actually using the resource right now and free up resources for others to use. And the only real way to do that is to go non-blocking. I mean, historically, most applications have actually, things like WebSphere or WebLogic or all these big app servers have been blocking. I mean, they spawn up a single thread per user request, blocking all the way down to the database. That doesn't work any longer. It doesn't scale. I mean, you will very easily hit the roof where I mean, on the number of users you can actually serve. Okay? And another nice thing is that EventDriven gives you concurrency by design. It's nothing that you have to really worry about. So you're raising the abstraction level. I don't know if you used to work with like threads and locks and the low-level primitives. Like EventDriven sort of programming gives you sort of an escape route from that, since you think in terms of workflow instead of low-level plumbing, which is very nice. So also things like push instead of pull, and on-demand execution. Systems that are like inherently lazy, that doesn't do anything more than actually being asked for, etc. So that is the fundamental sort of underlying, I think, trait that we need to embrace. On top of that, and sort of tied into that, is scalability. And scalability, so the natural benefits of scalability are elasticity, being able to fully embrace the cloud, and fire up nodes on the fly as needed, and also scale down if needed, right? And I think the scalability should really be, first, a deployment decision. It should not be sort of built into like hard-coded into your application by design. It should be something that you can actually do when you deploy. But even more, if you have a very loosely coupled architecture that event-driven programming gives you, this actually can be a runtime decision. The runtime can actually adaptively change how your application is deployed, which topology it has, according to how the application is being used. And this is very important. This is also something that we work a lot trying to address. So, I mean, the natural benefits of this is, I mean, you be more cost efficient. You don't need like larger cluster or more machines than you actually need for the time being. You don't sit there with excessive hardware. I mean, just waiting for Christmas to come where you might need it, or the other way around and worrying that you have too few machines. You actually scale with predictability. And how can we do that? And as I said, event-driven programming is really the foundation. And I think if you have that, you're already in very good shape to deal with scalability. And because if you already based your sort of the way you interact with your components inside your application based on async message passing, then you have what we call location transparency built in. Then it doesn't really matter if the component I'm talking to runs on another machine in another data center even. I'm just having a handle to him, I'm talking to him here. And even more importantly, the runtime can actually have the freedom of moving the component around. It might be actually moving him over here because so I can use that component in the local context instead of talking across the wire, or vice versa. And this is all enabled by event-driven programming and the sort of loose coupling that we get there. So it's also very important, I think, that when it comes to distributed computing, as you probably know if you've done any of that, that's really, really hard. Okay. 10 minutes left, or cool, thanks. So I think it's very important that we make it sort of it explicit in the programming model. Historically, we've been sort of dealing with I mean, sort of the way it's been solved historically is, in my point of view, have been too much magic. It's trying to hide sort of the complexity of distributed computing, and that just gives us an abstraction that just leaks too much to really be useful. Because if something goes terribly wrong, which it will if you run on a distributed system, then there's really there's just a black box. There's really nothing you can do about it. At least very little you can do about it. Okay, so fully embrace the network. That brings us to sort of the third trait, which is resilience. And I think this is unfortunately something that's to a large extent been ignored by our industry. I mean, and if not ignored, it's sort of been bolted on afterwards. I mean, let's build the system, and then we have to make it resilient, and then we bring in whatever, turn on sort of clustering and robotic server or something like that, and run into all kinds of problems, cascading failures or whatever there is. It's not something that you should bolt on afterwards, actually. It's something that should be built into the model. It's something that should be designed around. And I think it's important to have a programming model that makes failure first class. So you actually you see failure as a natural sort of state in the life cycle of the application. And this is what, for example, Akka does to the middleware layer. You have a way of working with and manage failure in an even declarative way. Sure. So the benefits with this is that then we get applications that can actually heal themselves. It's not like a one-off that either your whole machine goes down and your system has like to reboot that. The application inside itself can actually heal itself. And sort of the key to that is to build up your system in compartments, right? So you can isolate the failure and then have failure management separated out of these compartments to avoid things like cascading failures. And the interesting thing is that then you get full decoupling between the business logic that is fully clean and separated out of the way you're actually managing the failure. So they make software easier, both easier to write, understand, and evolve. And you get a fully declarative model how you can actually manage failure and sort of have the system heal itself. Okay, and my last point is also extremely important, since it's sort of built on top of an event-based model. It works with the same semantics in a distributed environment by design. That means that you can have components watching other components on other nodes, even on other data centers, and have sort of the failure being reified and managed as a whole. So all these three traits, event-driven at its core, scalability and resilience, really form sort of a cohesive whole where they support each other. And I really believe that is sort of the future of how we need to implement or write systems today to address the ever-changing challenges of cloud computing, etc. I mean, for example, Akka, we have people customers running Akka all the way from handheld phones all the way up to 1,000 node clusters. So you can really scale it up and down as you want. Okay? And interactiveness is sort of the fourth sort of element in this story, in which we need to create a rich and engaging UI, etc. And this is where the plain web framework comes in for us. We have WebSocket-based service-sent events. We have APIs for streaming, etc. like that. So you can get this rich, rewarding, real-time sort of user experience. So the Typesafe platform, if you're going to give like sort of how that supports this way of thinking, is that you might have a problem solving, you want to write a mobile app or real time or big data problem or whatever. Then we have something called the Typesafe Activator that gets you started as a bootstrapping tool. And when you have gotten started, then you start developing applications. Then you can do that either in Java or in Scala. We support both. As I said, Typesafe has the Scala programming language, but we also have, for everything we do, has first-class Java support. Okay. And then once you deploy onto our runtime with the JVM at its core, Akka for the middle layers, so the scale out, and the plain web frame to give you this rich, real-time sort of user experience if you happen to have a web UI or sort of REST-based services, etc. And we also have the types of consoles to give you monitoring management and so into the picture. Okay, so if you want to now sort of get a feel for our stack, we just released in developer preview this Typesafe Activator. So you go to typesafe.com/platform/get it started, and then you can download that and get started with building a reactive application right now. And I have a couple of minutes. I was just going to try to show you how it's working. So I just download the activator here. You can just open it up. It launches sort of the underlying runtime. So yeah, it's a little bit, the screen resolution is a little bit too small here. But here basically you can create a list. You can see all the templates that we have. We have a template repository where our users add templates themselves. And here you can, for example, pick the reactive stocks application. We create that It's really, really small here. So here we have on the left-hand side, we have the tutorial that comes with it, so it explains what it's all about. I can minimize that so you can see here. So here you have the code. You can see it's already started compiling. You can browse into the code and start seeing things like your actual components here. You can even edit the code and have it will automatically then recompile, etc. You can see errors and stuff. So this is really mini IDE, but it's really just a getting started tool. So just save this now. So now if we then go back here, so you can compile your app, you can run it, and you can also then test it out. And let's see, now we're going to start it up again. And this is a little application that sort of encompasses our whole stack. It has the web framework for doing reactive. It's a little app that goes out and checks if you should buy or sell a certain stock, and it's all powered by the Akka runtime, so you can fully scale this out on hundreds of nodes, and also written sort of based on the Scala programming language at the end. So this is just one of the sort of the simple templates we have. It's easy to get started. We have a whole bunch of other ones to give you a feel what it is to like write application is new, like event-driven, scalable, and resilient world. So I encourage you to take a look at that if you're interested. So that was basically everything I had. Go to typesafe.com and find out more. And thanks. Do we have time for questions? So, any questions? So now you all know what to do. Huh?
How do you charge for this? Or?
Yeah. Okay. That's a good question. So everything we do is fully open source. It's a Apache 2 license. We charge you when you go to production. You have the option of buying subscription for support. We have developer subscriptions as well to help you along the way, but we also production subscriptions. We also sell trainings on our platform, like courses on Akka, Scala, Play, and mentoring and stuff like that. Yeah.
So as part of deploying it into thousands of nodes in cloud, how does that work with Akka? Amazon Cloud or?
Yeah, we don't have a provisionings or a service ourselves, but our customers normally use Amazon's tools to actually spin up the machines and to manage the actual physical virtual machines, or if you have your own data center. But for example, Akka is based on on a cluster membership gossiping protocol. So you can just spin up nodes; they will automatically find each other, and if the application is sort of configured to be clustered, it will automatically move sort of the applications or partition that out on the available nodes right now.
It's just a configuration.
It's just a configuration, and it's also you both configure how it should behave when you boot things up, but also you can configure how it should behave under load. So you can set thresholds. I mean, if CPU goes over a specific threshold, or if I get n number of messages per second or whatever, then the system should automatically adaptively react to that and start repartitioning your application across the machines that you have available. Or if you shrink the cluster for some reason, then it will like move over the ones from the machines that you take down and sort of repartition on the currently available nodes. And resilience is fully built into that as well. So if one node goes down, I mean, the components that are running there will automatically be moved over and continue running on the existing machines.
Is it similar to a load balance service where the current connections are getting impacted by the failure?
We don't. I mean, we have routing and load balancing built in, right? But if you have if you expose a service to your clients, then you normally have a load balancer on top of your whole application stack as well. So you can slice the cake in many different ways. Okay? That's it. Thank you.